Related rates problems in calculus involve finding the rate at which one quantity changes with respect to another quantity, typically with the help of derivatives. Here's a step-by-step approach to solving related rates problems. Step 1. Read the problem carefully and identify the relevant quantities. Step 2. Assign variables to the changing quantities. Let's say you have two quantities, A and B, and you need to find the rate of change of A with respect to B. Assign variables to these quantities, such as A, t, and B, t, where t represents time. Step 3. Determine the relationship between the given information and the variables. This is usually expressed as an equation involving the variables. It may be an explicit equation, or you may need to use geometry or other principles to derive the relationship. Step 4. Differentiate the equation with respect to time. Apply the chain rule if you need. Step 5. Substitute the given values into the differentiated equation and calculate the rate. At this stage, you'll have a mix of known values and its derivatives. Substitute the known values and the rates of change given in the problem into the equation. Step 6. Don't forget units. Remember to include units in your final answer to indicate the rate of change. It's important to practice with various related rates problems to gain familiarity with different scenarios and techniques. As you solve more problems, you'll become more proficient at identifying the relevant information and applying calculus concepts effectively. Let's take an example. A calm pond creates concentric waves when a stone is thrown into it. The radius of the concentric wave is increasing at a rate of 1 foot per second. When the radius of the wave reaches 10 feet, at what rate is the area of the wave increasing? Step 1. This problem is a related rates problem involving the relationship. The area of a concentric circle is influenced by changes in the radius. And, we need to determine the rate at which the area of the wave is increasing when the radius is 10 feet. Step 2. The changing values are the radius, denoted as r, and the area of the circle, denoted as a. Let's assign the rate of change of the radius with respect to time as dr, dt, and the rate of change of the area with respect to time as dA, dt. Step 3. The radius is increasing at a rate of 1 foot per second, and the area of the circle, A, equals pi times r squared. Step 4. Our goal is to find the rate at which the area of the circle, A, is changing with respect to time, t. This can be found using the chain rule. The chain rule states dr squared dt equals 2r times dr dt. Therefore, we can write dA dt equals 2 pi r dr dt. Step 5. Now, we can substitute 10 for r and 1 for dr dt into the equation. Finally, dA dt becomes 20 pi. Step 6. Hence, the area of the concentric circle is increasing at a rate of 20 pi feet squared per second. See you next time.